In this video, I'm talking about auto-adding sensors via an Advanced EXE script. So for this, I'll give a rough example. This example is not really useful in the real world, but it is very good at demonstrating with minimal amount of code. So for this example, it will be, we want to monitor all of the files in a folder. And we don't want to just monitor the count of them. Specifically, we want to monitor the age of the file and the file size. Now, obviously, we could set this up manually using the file sensor. It monitors both of those things. And say, for example, we had 4 files in a folder. We could just manually set up that file sensor 4 times. But what if this list of files changed? Let's say every month or so, 1 or 2 of the files got removed and another 1 or 2 of files got added, and you wanted to make sure that it was always up to date. One method of doing this is using the Advanced EXE script sensor and writing a script that enumerates all of the files in the folder and returns the data that we want. So let's run through that situation quickly. There are some downsides, and I'll show you those once we've implemented it. So I'm just going to add a new device under our diet group. I'll set this up to localhost, and then I will add a new sensor, searching for exe, and then adding the exe/script advanced sensor. I'll just call this files in folder. And the script that I use will be files in folder. Now, before we go set this up, let's go have a look at the code. So this is the sample code. It is hard-coded and the bare minimum amount of code necessary. So you can see the folder name is hard-coded. It gets all of the children of the folder, and then for each file in the folder, it will return the file name, the file length as one channel, and the file name and the how many minutes it's been since the last write as another channel. So back in PRTG, we can tell it had no parameters were necessary for this script, and we'll just come in and run this. So after refreshing, we can see that there's 2 files in this folder that it's picked up. 1.txt modified was 40,000 minutes ago, and the size of 1.txt is 10 bytes. So if we open this folder and we rename file 2 to file 3, and we'll rescan this, so now you can see that it's picked up information about 3.txt, but well, here's something you'll just need to get used to with PRTG. It's actually returning the same value twice. So if we run this again, now it's returning the correct value. It's the size of the file, and you can see that information about 2.txt has disappeared. This is the current view. If I went to look at the live data, I would be able to see historically that 2.txt's size was this, and now 3.txt's size is this, because it's the same file. And just because you rename a file does not change its modified date. So, side note. Okay, so after you run this for a while, depending on what you're actually monitoring, you might realize that there's a lot of channels that are returning no data, as in, say, this file doesn't exist anymore. There's no way to clean these out. PRTG doesn't let you delete data, which is a good thing. So the only way to start fresh is to start fresh. You would have to create a new sensor with the same parameters, the same script. You can't clone the device. Cloning the device will actually clone the channels. So recreating is the only method that will work here. And depending on what the data is, you may want to keep the data for a given amount of time. So let's just say this is the cloned one, and I wanted to retire this. I would just pause this. I would call it retired. I would put a date in there of when I could actually happily delete the data, say in 12 months time, and possibly just add the tag called retired as well, so I can differentiate between what sensors I paused for one reason or another and what sensors I paused because they're retired, and I can run that into reports and libraries, etc. One real-world example of this that I've set up is monitoring handheld devices out in a warehouse. We had 50 or so, and we were noticing some of the devices, the users would report battery levels just going down really quickly. So we wanted to analyze all of the devices and see if we could figure out any pattern to what it is, where they are, or who's using them. So setting up this to talk to our mobile device manager that managed all of the portable devices, we could return all of the battery levels every minute and graph this all. So we could see in one graph listing all of the channels, which device was degrading quickest, and then we could analyze that to see what is happening with the battery. In this particular case, it was actually a hardware issue that was running the CPU too hard and degrading the battery in about half the time. And while it was set up purely to diagnose one particular issue, we actually left it running because we found it very useful that after 3 or 4 years of these batteries being drained every day, sometimes twice a day, they would degrade. And to be able to identify a battery when it was no longer within spec, we could replace those batteries before the users would start complaining.